Dear friends, hearty welcome to today's session of online problem solving sessions for JAM and NET aspirants. Today we have Mr. Joseph Nelson with us. He has completed M.Sc from Cochin University of Science and Technology and now pursuing Ph.D. at Amrita Vidyapeetham, Coimbatore. His research area is cryptography. I would like to thank him for accepting our invitation to join with us. Hope that today's session will be fruitful to all of you. Once again, I welcome all of you to this event. Thank you.
Yeah, thank you. Today I would like to discuss few problems from the entrance examination of Tata Institute of Fundamental Research and NBHM. Yeah, this is a true or false question. Yeah, does there exist a function? Does there exist a continuous function f from R to R such that the image of rational numbers is a subset of irrationals and image of irrational number is a subset of rationals? That is a question. That is, yeah, if you are looking through this question, a continuous function maps a connected set into a connected set. Yeah, first we can consider the closed interval 0, 1. It is a connected set and its image will be another connected set. In R, in real line, connected set will be an interval of the form AB or this way or any one of this form. Yeah, whatever. For some rational numbers, its image is, and also it is given that it's not a constant function. It will be a non-constant function since the image of rational numbers is irrational and image of irrational number belongs to some rational numbers. That's why it cannot be f not equal to c. That's why we can say this f is not a constant function. Suppose such a function exists. Image of rational numbers in this closed interval 0, 1. Image of this thing will be image of Q will be a subset of irrational numbers, but even though this Q intersection closed interval 0, 1 is a countable set, so the image will be again a countable set. F of that will be countable. Similarly, the complement that is closed interval 0, 1 intersection Q complement, that will be a subset of Q. Since Q is countable, its subset is also a countable. But countable union of two countable sets is again a countable set. Union of two countable sets is again a countable set. That's why we can say that f of closed interval 0, 1 will be countable. But this is an interval. Interval that is some interval Yeah, definitely that will be a closed interval. Some closed interval AB. A closed interval which has only countable number of elements, which implies that interval will be a point, only one point that will be equal to some singleton set. That is a contradiction since this function is non-constant function. Okay, next we can discuss the next question. Yeah, these questions are from TIF 2019 question paper. Yeah, let the sequence xn be defined by x1 equal to root 2 and xn plus 1 equal to root 2 raised to xn. And we are taking the power, uh, the last element in the sequence for n greater than or equal to 1. Then whichever one of the following statement is true? Yeah, the first statement is the sequence is monotonically increasing. Yeah, then the second statement is the sequence is neither monotonically increasing nor monotonically decreasing. If the first statement is true, then the second statement is false. Directly we can say that. And the third statement, we cannot say anything about that with the previous things. Yeah, let's try to complete this problem. Yeah, first we can try to prove that. First we can write few terms in the sequence. X1 equal to, we know, root 2, and x2 equal to root 2 raised to x1. That is root 2 raised to root 2. Anyway, from the first assumption, we can say that x1 is less than x2. And now we can prove that the sequence is monotonically increasing. Now we got x1 less than x2. We can either use induction or we can directly say this, because this is a competitive exam. No need to waste your time for doing all the steps. Yeah, try to do with few steps whatever it's possible. And x1 less than x2, yeah, we know one thing. Then a raised to x1 less than a raised to x2 for a is greater than 1. X1 less than x2 implies a raised to x1 less than a raised to x2 for a greater than 1. Instead of a, here we are using root 2. So root 2 raised to root 2 is less than, that is root 2 raised to x1 is less than root 2 raised to x2. Here root 2 raised to root 2 is less than root 2 raised to root 2 raised to root 2. Yeah, now we got that this is our x2 less than, and this thing is our x2 less than x3. Yeah, by the similar way we can compute this thing, x3 less than x4 and x4 less than x5, and similarly we can continue, and this thing gives that sequence is monotonically increasing. Now what about the other options? And as a consequence of this thing, the second option is directly false. Option B is false. And the other thing, limit of xn does not exist. That is only possible if the sequence is not convergent. And we can prove that the sequence is convergent. We can prove that using the sequence is bounded above. A bounded sequence a monotonic increasing sequence which is bounded above is convergent. Here we can prove that the sequence is convergent by telling the sequence is bounded above. Yeah. First we can say that the first element root 2 is less than 2. That is trivial. And I'm telling that root 2 raised to root 2 is less than root 2 raised to 2. The similar argument that we have taken, that a raised to x1 less than a raised to x2 if x1 less than x2 and a is an integer, a is a number which is greater than 1. Now this is equal to 2. Now this x2 is less than 2. Similarly, x2 less than 2, then root 2 raised to x2 is less than root 2 raised to 2. That is equal to again 2. That's why x3 is equal, x3 is less than 2. Similarly, we can say that every element in the sequence is less than 2. Or we can conclude that the sequence is bounded above by 2. That's why this thing is also false, because that is a bounded sequence. Bounded sequence, and it's monotonic bounded sequence which is convergent. That's why that's convergent. And the limit of xn is infinite. We have already proved that that is bounded above. That's why limit of xn cannot be equal to infinity. That's why this is also false. And the answer is the sequence xn is monotonically increasing and limit of xn equal to 2. Yeah, what can you say about this question? Xn equal to 1 plus 1 by root 2 plus and plus 1 by root n minus 2 root n. Okay, for doing such problems, first of all, we can check the first element of this thing. That is x1 equal to 1 plus, x1 equal to 1 minus 2 root 1. That is equal to minus 1. And x2 equal to 1 plus 1 by root 2 minus 2 root 2. Yeah, anyway, we can check what we are adding with each term. That is x2 equal to x1 plus, we are adding this term 1 by root 2, and we are subtracting this term. For this, here we are adding, that's why here we are subtracting, and that's why we have to add this term plus 2 root 1, and we have to subtract this term minus 2 root 2. In the case of xn will be equal to xn minus 1 plus 1 by root n plus 2 root n minus 1 minus 2 root n. And we have to verify that whether this sequence xn is decreasing, increasing, or constant, or oscillating. Yeah, from the first and two elements itself, we can say that the sequence is not constant. Now we have to verify whether the sequence is decreasing, increasing, or oscillating. We can check what is this term, what we are adding with each last term. That xn is found by adding something with xn minus 1. We can check this thing, and this value will be 1 by root n plus 2 into root n minus 1 minus root n. And this thing, this part can be written as root of n minus 1 minus root n into root n minus 1 plus root n divided by root n minus 1 plus root n. Yeah, it will be equal to n minus 1 minus n by root of n minus 1 plus root n. Yes, this thing altogether we can write it as 1 by, that is xn minus 1 equal to 1 by root n plus 2 into, and this thing will be minus 1 by root of n minus 1 plus root n. This is equal to 1 by root n minus 2 by root of n minus 1 plus root n. Anyway, this term will be less than this thing will be this 1 by root n minus 1 plus root n will be greater than, no, this 2 by, this thing will be greater than 1 by root n. Yeah, we can. This 1 by root n minus 1 plus root n will be, we know one thing, root of n minus 1 is less than root n. That's why this thing is 1 by root n minus 1 root n minus 1 plus root n is less than 2 root n, and 1 by root n minus 1 plus root n will be greater than 1 by 2 root n. Yeah, multiply both sides with 2 will gives 2 by root n minus 1 plus root n is greater than 1 by root n, and we can say 1 by root n, and we are subtracting this term, from 1 by root n, and that will gives 1 by root n minus 2 by
Hello, Joseph. Someone muted your presentations. Hello.
hello. Okay.
Okay. Now it is clear, but
Okay.
your screen is not visible.
Okay. What about now? Is it visible?
Okay. Yes. Okay. Right.
Okay. I think you heard about other steps. Okay.
Okay.
The thing is decreasing. That's why we can eliminate all other options, and the option is the sequence xn is decreasing. Yeah, let's discuss next question. Yeah, this is also a question from TIFR 2019. Anyway, the TIFR is also making their exam by March of 2021. They are planned to conduct their exam. Yeah, this is a basic question that maybe you may be learned these things in your 12th standard. Maybe a simple question, but that was for the M.Sc and Ph.D. entrance exam. And the question is how to find the sum of the numbers. Anyway, this is not an infinite sum. This is just a finite sum, because this series is not convergent, or it's not bounded if you are taking a large number of values, and that's why this is a finite sum. We just need to find the finite sum. Usually like this question, suppose this thing is like this: 2 plus 2 plus 2. Any type of question you can apply the same idea of doing this in some in the form of 9, because just multiply and divide this term with 9. That will gives you 9 plus 99 plus 999 plus, yeah, plus that thing 999. That will contains n 9s, and each 9, this 9 can be written as 9 is equal to 10 minus 1, and 99 is equal to 10 square minus 1, and 999 is equal to 10 cube minus 1. Yeah, and similar way we can write this and all divide by 9. There will be a 9. We have multiplied and divide this term with 9. That's why we can write it as 1 by 9 into 10 minus 1 plus 10 square minus 1 plus 10 cube minus 1 dot dot 10 raised to n minus 1, and that will be equal to some 1 by 9 into 10 plus 10 square plus 10 raised to n minus, there will be n ones, that will be n, and this thing is a geometric progression with first term a1 equal to 10 and common ratio r is equal to 10. Then the sum is this term, this sum will be equal to a into r raised to n minus 1 divided by r minus 1, and only about this thing, and you can calculate this as this will be equal to 1 by 9 into 10 into 10 raised to n minus 1 divided by 10 minus 1, that is 9 minus n, and this is equal to 1 by 81 into 10 raised to n plus 1 minus 10 minus 9n, and this is the final answer, and we have that answer as first option that we have, and we can use that's the correct answer, and all the other answers are wrong. Okay, what about this question? For a sequence n of real numbers, which of the following is a negation of the statement limit of n tends to infinity n equal to 0? Here we have to find a statement which says that limit of n is not equal to 0. That implies limit of n can be anything. Limit n may exist or may not exist, and all these possibilities are there. A sequence an of real numbers is said to be convergent, or an converges to an converges to 0 if for any given epsilon greater than 0, given epsilon greater than 0, we can find a natural number n such that an minus an minus 0 mod n minus 0 is less than epsilon whenever this n greater than n. Yeah, by taking the negation directly from this thing, we can say that there exists some epsilon greater than 0. For any given epsilon, the negation will be there exists. For any given, we can say that by taking the negation for any given, we can say that there exists epsilon greater than 0, and what we have to say that there exists, and for any n we can find a n, we can find an n, but here for any n we are taking the negation, that's why for any n an minus 0 will be less than epsilon, and the negation that will be an minus 0 will be greater than epsilon. And that was for all n greater than n. And the next thing that will be for some. For some n greater than n. And the negation should satisfy all these things. And we can check the options that satisfy all these options. That is, first option, there exists epsilon greater than 0 such that the set an greater than epsilon is infinite. That is a possible answer. Because for if we choose any n, we can the set is infinite. That's why there will be an n which is greater than this capital N, such that mod an minus 0 will be greater than epsilon. That's why the first option is true. And what about the second thing? And this thing may not be true. Because suppose we are taking the sequence is some -1 raised to n by n. Sorry. The second option. Okay. Yeah, that may not be true because they are given for any m. Suppose we are taking the sequence some xn equal to -1 raised to n, and I am choosing and using I'm taking m equal to some 2, and the sequence xn here I have taken is -1 1 -1 1, okay, and m is equal to 2. For any n, this xn mod xn is less than m, that is equal to 2, because for all n mod xn equal to 1. That's why the second option, anyway the sequence is not convergent and not converges to 0, and which doesn't obey that thing. And the next question, there exists a non-zero real number a such that for e, okay, that's for every epsilon greater than 0, there exists n such that an minus a is less than epsilon. This is gives that an converges to a, that a is not 0. This is also true because an is uh, an does not convert here also. An limit of an not equal to 0. And next case is here the limit of an equal to a, and given that a is a non-zero real number. And anyway, we are taking by negation, we are taking the statement is false. We just need that thing. The statement is false. And the next option is for any a element of R and every epsilon greater than 0, there exists infinitely many n such that yeah, that thing. Yeah, and the statement D say that sequence an is not convergent. Sequence an is not convergent for any a, because if, suppose the sequence an is converges to 1, then the sequence an is not converges to 0, and that is a statement which is more higher than that thing, a limit of an not equal to 0. Actually, we are considering that the negation by means the statement is false. That's why this thing is also some true statement. The complement is true. That is, an is not a convergent sequence. This thing says that an is not a convergent sequence. Anyway, the statement D is more stronger than the thing that limit of an equal to 0. That is limit. This statement D says that the sequence is not convergent for anything. But we only need that limit of n times infinity an not equal to 0. That's also true here. Yeah, we can discuss next question. This function is known as Tommy function or popcorn function. That is f of x equal to 1 if x is equal to 0, and f of x equal to 0 if x is irrational number, and f of x equal to 1 by n if x equal to some m by n, with m comma n are integers and GCD of m comma n equal to 1. Yeah, which of the following statements is true? And this function is an example of a function which is continuous at uncountable number of points, and discontinuous at countably many points. Yeah, let's check that whether this function is continuous at rational numbers. Since For any rational numbers, I'm considering some p by q. I can find a sequence of irrational numbers. That is some xn. Xn is a sequence of irrational numbers that xn converges to p by q. Yeah, without loss of generality, I am taking GCD of p comma q equal to 1. Then this f of p by q equal to 1 by q. But what about this sequence? This sequence xnr I have taken from xn I have chosen from q complement. Then f of xn will be equal to 0 for all n. Yeah, and anyway that sequence 0 converges to 1 by q. That's a false statement. That's why in general this function is not continuous at rational numbers. And now we have to prove that this function is continuous at irrational numbers. Yeah, let's consider. Here I am using the continuity by the idea of sequence. Suppose we need to prove a function f is continuous. I forgot to tell that. At x, we can find for any sequence xn that converges to x, then f of xn should converges to f of x. That is the definition. That is an equivalent definition corresponding to continuity using the sequences. Here I have used that thing. In the case of irrational numbers, now we have proved that in the case of rational numbers, this function is not continuous. Now I am taking the case of irrational numbers. Let x be an irrational number. Then I have to find a sequence and yn be a sequence that converges to x. Suppose yn have some zeros. Yn contains irrational numbers. Yn consists of irrational numbers. For some ym is irrational, then f of ym will be equal to 0. Without loss of generality, I am taking that that I don't want to care of this thing. That's zeros. And f of x equal to 0. That I know. I have to prove that f of yn converges to 0. And I have taken a sequence of rational numbers that converges to x. I'm taking from q. We need to check only for rational numbers. That's why I am taking a sequence from q. And I have to tell that this 1 by Qn, where 1 by Qn means each ym I can return as Pn by Qn with GCD of Pn comma Qn equal to 1. I have to tell that I have to prove that 1 by Qn tends to 0. 1 by Qn does not tend to 0 if this Qn is bounded. Suppose this Qn is bounded. Suppose this Qn is bounded. Then Pn also bounded. For example, if you are taking some irrational in between closed interval 0, 1 and Qn is less than m. Anyway, and rational in between 0 and 1, it will be some p by q with p less than q. Then p less than q. Suppose this Qn is bounded, then this Pn is also bounded. Then this p by q have only finite number of choices. We are taken a sequence. In that sequence, only finite number of rational numbers. That is not possible. A sequence have infinite number of terms. That's why this Qn cannot be bounded. Anyway, we have to find an epsilon sequence which converges to 0 for taking any sequence Pn by Qn and for any epsilon greater than 0, I can find an m such that one by n less than epsilon whenever n greater than m. We can prove this using Archimedean property. Then I am only considering that Pn by Qn with this Qn is greater than m. And the rest of the rational numbers will be finite. I'm removing that rest of the rational numbers. And from a infinite sequence, we can remove a finite number of terms. Then that will be again an infinite sequence. And clearly that function, that f of p by Qn converges to f of Pn by Qn will be less than 1 by m, which is less than epsilon. That's why f of Pn by Qn converges to 0. We have taken this is true for every irrational numbers. That's why the function f of x is continuous at every irrational numbers. This is the option B is the true statement. All other options are false. Yeah, this is also a simple question that we may have learned in our elementary classes. The set of real numbers in the open interval 0, 1 which have more than one decimal expansion. Yeah, first we can prove one thing. It's a simple thing you may have heard. 0.999 is equal to 1. First of all, whether it is true, yeah, this 0.999, let I'm taking x is equal to 0.999, this thing, and 9x will be equal to 9.9999, and 9x minus x will be equal to, I'm just subtracting this from this, that will be equal to 9. Then equating this thing gives x equal to, oh, I made a mistake here. Here 10x equal to 9.9999. Then 10x minus x will be equal to 9x. That is equal to 9. Then x is equal to 9 by 9. That is equal to 1. This is an usual proof. Then we have to prove that, and my assumption is every rational number of the form, every rational number that is some, for example, I'm taking 1 2. 1 2 I can write as 0.119999, this thing, and both of these things are representations are not at all okay, but and both of these the values are same. What we are doing this, let taking, I'm considering this thing, x is equal to 0.11999, and here the 999 starting from the after 3 positions from the decimal. That's why I am taking 100x. 100x equal to 11.999, and 100x minus x will be equal to 11.88. That is 99x is equal to x is equal to 0.12. Similarly, any rational number that has only finite number of terms can be represented like this. Just subtract the last term by 1 and adding 9s. For 0.34 will be equal to 0.33999999. Only possible for these type of rational numbers. That's why the answer for this question is countably infinite. There might be a question why it is not uncountable. For irrational numbers, there are infinite number of terms. And by comparing two irrational numbers, by means we are just comparing the nth term after the decimal place. We are just comparing the nth term in the decimal place. Suppose x1, x2, this thing, x1, x2, x3, xn. This is an irrational number, and this y1, y2, this is also an irrational number. By means we are comparing this thing equal to this thing by comparing this xn, xm equal to ym or not. Suppose xm not equal to ym, then suppose I'm taking this is equal to x and this thing is equal to y, then x not equal to y. That's why we got there are countably infinite real numbers in open interval 0, 1 which have more than one decimal expansion. Yeah. And this is also a simple question, that is f is an uniformly continuous function and g is also a uniformly continuous function from R to R. Then their pointwise product f of x into g of x is uniformly continuous. This is also a true or false question. True or false question. Whether there exists. Suppose we can find two uniformly continuous functions such that f of x into g of x is not uniformly continuous, then the statement is false. We generally have learned some uniformly continuous functions, which are f of x equal to x, which is uniformly continuous function, and f of x equal to x square is not an uniformly continuous function. Sorry, I'm using the same symbol. Some h of x equal to x square is not an uniformly continuous function. And this is uniformly continuous. And this is not. That's why I am choosing g of x equal to g of x is also x. And x is a uniformly continuous function. Then their product g of x into h of x is equal to x square. Which is not uniformly continuous. That's why this statement is false. False. Yeah. Next we can learn something. We have to know the definition. Interval of convergence of series. That is, we have to find an interval of R. We have to find the interval of R, that is, that may be open or closed A comma B, maybe this thing or this thing or any one of these thing, such that x belongs to x belongs to this interval, this summation. I'm just taking this xn to be some f of x equal to x plus 1 minus x plus 1 square by 4 plus x plus 1 square x plus 1 cube by 9, and continuing in this way. And we have to find the value for what all are the values of x for which this series converges. For the convergence of series, we usually there are a lot of techniques. One technique is we are using the ratio test. That is an plus 1 the term of the series, that is an plus 1 by an mod n plus 1 an is less than 1. Suppose this thing is less than 1, then the series is convergent. Then series is, I am taking a series, just consider fx equal to summation an x raised to n. And anyway, this is a real sequence, n is a real number. Then I'm telling this sequence f of xn is convergent. F of x is convergent if one more thing, this limit should exist. An plus 1 by an is less than 1, and limit should exist. That is the main thing. Oh, sorry, I made one more mistake here. Yeah, f of x equal to summation n equal to 1 to infinity an, only that much. Here, instead of an, we have x plus 1 all raised to n divided by n square. Here some plus or minus is there, but I am taking mod n is equal to this thing, and mod an plus 1 is equal to x plus 1 all raised to n plus 1 divided by n plus 1 square. And an plus 1 an plus 1 divided by an is equal to x plus 1 raised to n plus 1 by n plus 1 square into that x plus 1 raised to n by n square. Yeah, this thing will comes to here. That will be n square by x plus 1 all raised to n. Yeah, finally this will be equal to x plus 1 divided by, or x plus 1 into n by n plus 1 square. n by n plus 1 will be tending to 1 as n tends to infinity, and that's usually, and an plus 1 by an, we need an plus 1 by an is less than 1, which implies, which gives x plus 1, and I am considering this thing to be 1 because n by n plus 1 will be tending to 1 as n tends to infinity, and their square, just only finite number of product, that will be again 1, gives x plus 1 is less than 1. Sorry, here mod x plus 1. I had to take mod everywhere. Mod x plus 1 mod x plus 1 less than 1. Yeah, this we can write as minus 1 less than x plus 1 less than 1, and subtracting 1 from both sides, we get minus 2 less than x less than 0. Now we have to verify whether this series is convergent at x is equal to 0 and x is equal to minus 2. We have to check whether here less than or equal to. We have to verify whether the interval. And at x equal to 0, the series become, I'm taking x is equal to 0, then 1 minus 1 by 4 plus 1 by 9 minus 1 by 16. Yeah, this is an alternating series. That is just plus minus plus minus. Alternating series with each term is 1 by 4, and each term is just less than the previous thing. 1 by 9 is less than 1 by 4, and 1 by 16 is less than 1 by 9, and nth term tends to 0, and that's why this series is convergent for x is equal to 0. X equal to 0, convergent. And at x equal to minus 2, at x equal to minus 2, this thing will be x equal to minus 2. First term will be minus 2 plus 1. That will be minus 1. Next term will be minus 2 plus 1 square by 4. That is 1 minus 1 by 4. Then minus 1 by 9 minus 1 by 16. This is equal to minus of summation 1 by n square. This is anyway, this is a convergent. That's why this function is also convergent at minus 2. So the interval of the convergence of the series is minus 2, comma 0. And this is a question from NBHM M.Sc 2012. Yeah, another question is from, this is also from NBHM M.Sc 2012 question paper. Pick out the functions which are continuous at least at one point in the real line. In this question also, we can use the idea of sequences for proving the continuity of a function. A function f is continuous. F is continuous at x. Then for any sequence xn that converges to x, then f of xn, sequence f of xn should converges to f of x. For the first question, f of x equal to 1 if x is rational. We can prove that f is nowhere continuous. For any rational number, let x be rational. X be rational, and we can find a sequence of xn from irrational numbers. Yeah, this is possible because of our density theorem. That is, irrational numbers are dense in R. Or rational. Similarly, in the case of if you are choosing x is rational number, we can find a sequence of rational numbers that converges to x by using rational numbers are dense in R. Xn element of Q complement. That is, xn is irrational number. Then f of xn will be x is rational. F of x is equal to, then f of x is equal to 1 and f of xn will be equal to 0. And this sequence xn does not converges to 1. F of xn does not converges to 1. Since f of xn's are 0, then limit of f of xn, that is f of xn converges to 0, and that is not equal to f of x. That's why f is not continuous at rational numbers. Similarly, we choose x from irrational numbers and a sequence xn from rationals. Then f of xn will be 1 and limit of f of xn converges to 1 and f of x will be 0. That is, x belongs to Q complement, we choose x belongs to Q complement, and then xn belongs to Q. F of x will be equal to 0 and f of xn will be equal to 1 and f of xn converges to 1, which is not equal to f of x. In both rational number and irrational number, the function is not continuous. So the first function is not continuous. That function is nowhere continuous. First option is false. Then what about the second option? Usually doing these problems, we just look for the directly we can check it by just consider the functions. Here x is rational, then the function is x, and x is irrational, the function is 0. Just look this is x-axis and y-axis, and write the function f of x equal to x. That will be function like this, and consider the function f of x equal to 0. That will be a line, and the function f of x will be continuous at this intersection of points. Okay, that will be an easy technique for doing such problems. Similarly, this question, sin pi x, Here also we just consider the function. Sin pi x will be a function like this. And that is at rationals, and other case that function is 0 in the case of irrational. That will be here if x is irrational. The function will be touching, intersecting here, 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 all these points. So the function will be continuous at these points. And we can go for the next question. Next question, we have to find a limit of a sequence actually. The sequence. Usually for doing these problems, we have to multiply this with its conjugate. Its conjugate will be something root of n square. We are using the idea of a square minus b square is equal to a minus b into a plus b. By using by multiplying like this, we will get this square root. We can remove the square root. Instead of a, we can use a is equal to root of n square plus n, and b equal to root of n square plus 1. Then we can get multiply this sequence with its conjugate. Then we get minus root of n square plus 1 into root of n square plus n plus root of n square plus 1 divided by root of n square plus 1 n plus n square plus 1. Yeah, in the numerator we will get n square plus n minus n square plus 1. And in the denominator we have root of n square plus n plus root of n square plus 1. And numerator will be equal to, yeah, this n square and this n square will get cancelled, and this will be equal to n minus 1 divided by this denominator. But from this denominator, I am taking the n outside. By taking, here I can write it as n square into 1 plus 1 by n plus root of n square into 1 plus 1 by n square. This thing is equal to n minus 1 by n into, I am taking this n square outside and it was root, that will be n, 1 plus 1 by n plus 1 plus root of 1 plus 1 by n square. And this is equal to, I am splitting the numerator, that will gives 1 by root of 1 plus 1 by n plus root of 1 plus 1 by n square minus 1 by n into root of 1 plus 1 by n plus this term. Yeah, this will result in, and as n tends to infinity, 1 plus 1 by n tends to 1 by n tends to 0, and 1 plus 1 by n will be 1, and this term will goes to 1. Similarly, this term will also goes to 1, and this will be 1 by 1 plus 1. 1 plus 1 is 2. 1 by 2 minus, as n tends to infinity, this n tends to infinity, and this term will goes to some finite value, and due to this n, this term will goes to 0, and the limit will be equal to 1 by 2. Yeah. Okay. Yeah, we can check this question. This question will be somewhat like that. We have done. Yeah, summation n equal to 1 to infinity. Pick out the convergence series. We have to check whether this series is convergent or not. For the last question, we have used the idea of a square minus b square equal to a minus b into a plus b. Since by squaring each term, that will we get a square free or square root free number. Here it is taken third root. Third root. That's why here we have to use the idea of a cube minus b cube is equal to a minus b into a square plus b square plus ab. Here we have to choose a is equal to n cube plus 1 raised to 1 by 3, and b is equal to n. Multiply the terms with a square plus b square. Multiply and divide the term of this term by a square plus b square plus ab. We will get n cube plus 1 all raised to 1 by 3 minus n into n cube plus 1 all raised to 1 by 3 square. That will be all raised to 2 by 3 plus n square plus n into this term into n cube plus 1 all raised to 1 by 3 and divide by the same term. Yeah, and the numerator will be equal to n cube plus a cube minus b cube form. There a equal to this thing, that is n cube plus 1 all raised to 3 mean b, this 1 by 3 will get cancelled, and b cube will be n cube divided by this n square plus 1 all raised to 2 by 3 plus n square plus n into n cube plus 1 all raised to 1 by 3. And the numerator will become this n cube and n cube get cancelled, and 1 by this term. This term will be here. But here this sum, the denominator is greater than n square, because all other terms are positive. Just adding this term is positive, this term is positive. That's why our term will be less than 1 by n square. This term, this n square plus 1 all raised to 2 by 3 plus n square. I'm just telling this term will be less than 1 by n square. But all the terms are positive. But we can use the idea of comparison test. Comparison test is like that. If a series an, consider series an and bn, both an and bn are positive for all n, and an is less than bn for all n, and then summation bn converges imply that summation an. Now using this idea, we can use bn is equal to 1 by n square. We know summation 1 by n square is convergent. That's why our series is convergent. So the first term is convergent. Then what about the second option? Yeah, second option is n plus 1 all raised to n by n raised to n plus 3 by 2. N plus 1 all raised to n divided by n raised to n plus 3 by 2. I am just taking the terms. One term to be equal to, nth term will be equal to n plus 1 by n all raised to n into n raised to 3 by 2. And just considering this, here I am taking another test, that ratio test. I am taking another sequence. Here the statement an, summation an and summation bn are ratio comparison test, because an and bn are two series. Summation an and summation bn are series with limit of an by bn is finite, with an comma bn greater than 0 and limit of an by bn is finite. Then an and summation an converges if and only if summation bn. This theorem we usually use for testing the convergence of a series. Here I am taking another series, summation 1 by n raised to 3 by 2. You have learned that summation 1 by n raised to p is convergent whenever p greater than 1. Converges for p greater than 1. And that's why this term is convergent. This series is convergent. Since 3 by 2 is greater than 1. Now I am taking this to be my Bn, and An by Bn will be equal to, anyway, all the terms of this sequence are positive, and this Bn is also all the terms are positive. Then An by Bn will be equal to n plus 1 by n all raised to n by into n raised to 3 by 2 by, this is An, and our Bn will be 1 by n raised to 3 by 2. And this n raised to 3 by 2 and n raised to 3 by 2 will get cancelled, and that will be equal to n plus 1 by n all raised to n. This is equal to 1 plus 1 by n all raised to n. And limit of this thing will be equal to, and limit of that thing will be equal to 1 plus 1 by n raised to n is equal to e, which is a finite integer. That's why summation, our given summation n plus 1 all raised to n by n raised to n plus 3 by 2 is also convergent. Next case, where to consider next case, this is summation 1 by n raised to 1 plus 1 by n. This 1 plus 1 by n is greater than 1. Yeah, we may think that this this series will be convergent. We may compare that with our p-test summation 1, but actually that is not. That is a divergent series. That is summation 1 by n raised to 1 plus 1 by n. Here also we can use the limit comparison. I'm taking some Bn is equal to 1 by n. Then, and this is my An. Then An by Bn is equal to 1 by n raised to 1 plus 1 by n by 1 by n. That is equal to 1 by n raised to 1 by n. That is nth root of n. 1 by nth root of n. Then limit of n tends to infinity, n raised to 1 by n equal to 1, which implies limit of n tends to infinity an by bn equal to 1. Here also it is a finite value, and which is implies here an and by this comparison test we can say that an and bn converges or diverges together. It's a finite value. Since bn summation 1 by n is divergent, this thing is also divergent, and our this is not true. I think our time is up, or should we start for the questions?
Yes. Okay. Okay. Thank you, Joseph.
Okay. Yeah. Okay. I think
So
few doubts are there.
okay. Okay.
Okay.
So, dear students, if you have any doubt regarding the questions that we have discussed, you can ask now, and also you can make your comments about the class. So please come forward. You can unmute your mic and ask your questions.
Hello, sir.
Hello.
My name is Srilakshmi. The class was excellent. Actually, solving such TIFR and NBHM questions gives me a lot of idea to solve these problems. So, thank you so much, sir, for conducting this lecture. And thank you, sir.
Okay, thank you, Srilakshmi. Thank you. Okay, others, please keep your mic unmuted and express your views.
Sir,
Yes.
sir, myself Ramya. Sir, I'm having a doubt regarding one question.
Okay.
Sir, there was a question regarding to discuss the negation of limit n tends to infinity n equal to 0.
Okay. Okay.
Sir, could you please explain the third option once more?
Okay. Definitely.
Thank you, sir.
Any other questions?
No, sir, just that one.
Yeah, just a second.
Okay.
I have to just write something.
Yeah, sure, sir.
I have given the third option was and our negation was limit of an not equal to 0. That was our question. We have to find the negation for this thing. Am I right?
Yes, sir. Yes, sir.
Yeah. And their answer was there exists a such that for every
Epsilon.
epsilon greater than 0, there exists an element of n with an minus a less than epsilon
Yes, sir. Yes, sir.
for all n greater than equal to n.
Yes, sir.
Yeah, this is the definition for a limit of an equal to a.
Yes,
Am I
sir.
right?
Yes, sir. Yes, sir.
Is it is necessary for limit of an not equal to 0?
So why is that there exists a part is what was the confusion actually?
Yeah, actually here telling that limit of n not equal to 0.
Yes, sir.
Does that implies that limit of n exists and limit of n is some any other real number?
Okay, yes, sir, it can mean that.
Yeah, that can be true. That's do you get the idea? Just a second. I'm taking limit of n equal to
It can be any other number. Does it
yeah
suggest that, sir? Okay.
yeah limit of n equal to 1. Yeah, and this does not imply this thing. Limit of n not equal to 0
Hmm.
does not imply this thing.
Okay, sir. Yes, sir, I got the idea.
Okay, you got the idea.
Yes, sir. Thank you so much.
I'm also some confused in that place. That's why I don't know. I made some mistake in the beginning. That may be. Okay.
Yeah.
Are
And
you okay?
sir, the questions discussed were very useful to us, sir.
Okay.
Especially for I'm preparing for NET exam, and it was
Okay.
very useful for me. And thank you for your effort and time, sir. Thank you, Vinod, sir, for conducting this class.
Thank you. Thank you, Ramya.
Yes, sir.
Okay, others.
Yeah. If there's time, I have one more question. That may be some example of a question. Usually, this type of questions may be
Yeah.
useful. Yeah, this is also a true or false question. I don't know from which question paper. I have seen this question paper in somewhere. Does there exist a function f from R to R with f of x into 1 minus f of x equal to x square? and the answer is false. And usually this type of questions are seen in some question papers. In this type of questions, you have to just take this f of x is a, I'm telling that just a real function, not telling about a continuous function. Then in this case, just consider f of x as a real value. I'm just considering f of x as some y. Then f of x into 1 minus f of x will be equal to y into 1 minus y. This is equal to y minus y square. And I'm just telling this is equal to some h of y. And the derivative, and the I'm trying to find the maximum of this thing. That is s dash of y will be equal to 1 minus 2y. And h dash of y equal to 0 implies y equal to 1 by 2. And h of 1 by 2 equal to 1 by 4. Anyway, this is the h of h double dash of y is equal to minus 2, and h double dash of y at 1 by 2 will be again minus 2, that is negative. That is h of 1 by 2 equal to 1 by 4 is the maximum value that can be obtained for y into 1 minus y is less than or equal to 1 by 4. That's why f of x into 1 minus f of x, this is also a real numbers which is less than or equal to 1 by 4. But this x square is greater than 1 by 4 whenever mod x greater than 1 by 2. That's why such a function does not exist. Yeah, I think it's enough. I don't. Hello?
Okay, okay.
Yeah, is there any
Anyone
question?
else? Okay, dear students, if you have anything to ask or share, you can do it now. You can express your comments and views. Hello. Someone is asking about how to can we get some IIT JAM mathematics lectures. Some lectures are being uploaded in our YouTube channel. You can go through that. I have shared that YouTube channel link. In that channel, we had uploaded many lectures regarding the will be helpful for JAM preparations as well as for NET preparations. Okay. So is there anyone have with any questions or comments? Otherwise, we will wind up. Okay. Okay. Let me thank Joseph Nelson for being with us with this presentation. I hope I feel very happy with that. We had many participants throughout the session. Now I think, okay, it is almost 1.5 hours is over. So maybe due to low network, some of them students may left out. But anyway, during the sessions, we had a good participation. I hope that the session was really useful for their preparations for JAM as well as NET exam. Okay, once again, I thank Joseph for being with us. And also, I would like to thank all the students who have actively participated in this problem solving session. With these words, let us wind up here. We will be on the next weekend. We will be with some other resource person on some other topic. We will inform it in our WhatsApp groups. Okay, thanks everyone. Wish you all the best. Thank you.
Thank you.